Now that we know what Wei is and how it relates to Ether, we can move on to talking about the gas system in Ethereum. The gas system is meant to measure how much work we have completed in Ethereum. If you write some amount of code and deploy it to the server and have the server host your code, you have to pay money for that, right? So it's the same exact token with the world of Ethereum. So in order to get something or someone else to run our contracts, we have to pay them money. This payment is in the form of gas. Anytime we send a contract to the Ethereum network, there's some amount of gas price attached to it. Let's write an imaginary function here, and we're going to review the function in terms of gas or cost that it would take to run. So we're going to create this, whoops, let me backtrack here. We're going to create this function called doMath. And I'm going to pass in a couple parameters, int A and int B. And then in here, we're going to do A plus B, B minus A times B, and A is equal to 0. And we're not going to pass any value to it or anything. I'm just curious, like, what would it take to pay someone to run this code for me? So I can break down the price of each of these operations with a little spreadsheet, and you can see how much gas it would cost to execute on the Ethereum network. And so if I go there now, this is the spreadsheet that I'm talking about, and you can actually Google this spreadsheet. And for the different prices and everything, you don't have to like memorize it. Just be aware that it exists. In column G here, we have a description of different operations that can be executed in our contract code. Then in column C here, we find the price and gas of each of those operations. So to add, I'll do this. So to add an addition operator would cost, I would have to pay 3 gas. To subtract, right, it would be 3 again. To multiply, it would be 5 gas. To check to see if two values are equal, where is that? Let's see where it is. Did I pass it? Less than, greater than. Equality comparison, here it is. It would also be 3 gas as well. So how does this gas get executed and applied to a transaction? And what is gas anyway? So I'm going to pull up a diagram to explain that. And I'm going to share that with you. I'm going to resize it so that you can see it better. All right, so let's look at this diagram. It's going to break down the function in terms of gas prices, get a better idea of how it works. So the first thing to be aware of is that whenever we issue a transaction that modifies the blockchain in any fashion or form, we have to specify 2 properties inside our transaction object. This is the amount of Wei or money that we're offering per unit of gas. So if I were to offer a gas price of 10, that means I'm willing to offer 10 times 3 or 10 Wei of unit per gas or 30 Wei to add 2 numbers together. The other property is start gas or gas limit. These 2 terms are identical. This reflects the total number of units of gas that we're willing to spend with this transaction. So it might seem like we're always going to know the amount of money or gas that we're going to spend ahead of time. We can very easily look at the series of operations and add them all up from the spreadsheet. However, there are many types of codes that we can write where we can't easily compute the amount of gas it's going to take ahead of time. So what if I run a for loop over a collection of records that might grow or shrink over time? In that case, it'll be more challenging to estimate how much gas will be consumed because maybe we might run that for loop one time or we might run it 1,000 times. The difference between the two will be a tremendous amount of gas. So the purpose of gas limit is to say we're willing to pay at most this many units of gas to call this function. So with this in mind, let's imagine that we issue a transaction to run the do math function. So I'll pull up another diagram. And in that diagram, we'll see that we issue a transaction and provide a gas price of 300, which means we're willing to spend 300 Wei per every unit of gas, and we're willing to spend 10 units of gas. So let me pull that up so you can see what I'm talking about. Here it is. Share that with you. There it is. Size this one. All right. So again, we're issuing a transaction and we're going to provide a gas price of 300, which means we're willing to spend 300 Wei per every unit of gas, and we're willing to spend 10 units of gas. So at most, don't spend more than 10 is what I'm saying here. That is the absolute limit. So we submit this transaction to the network and it would invoke our do math function, and then all the lines of code inside do math would start to execute. So add 3 gas, right? When you're going to add, subtract another 3 gas, multiply, that's 5 gas, equality comparison, that's another 3 gas. So in total, it's 14 units of gas for the transaction. But I said we're only willing to spend 10. So what happens in a case where we need some amount of gas, but we allow a lower amount? We don't provide enough gas limit. Well, for every operation that is executed inside of our contract, we execute an operation, and the person who is executing that code checks to see the current amount of gas that has been spent and how much is available. So in the case of our function, we would have a running tab that starts at 0, adds 3 more to get 6, adds another 5 to that to get 11. And as soon as we execute more steps of gas than we have available, the execution of our function immediately halts. When that happens, the person running our code says, hey, there's not enough gas to continue this operation, so we're done here, and no other code is executed. What if we saw this coming and said, okay, we're willing to spend 20 gas? In this case, there's no problem. We only need 14 gas to execute the function, and we said we're willing to spend 20. Well, there's 10 here, but imagine we had changed that to 20. So there is 6 gas left over, and that would not be consumed. In fact, that gets sent back to us. So you only spend the gas that is actually consumed via executing your contract. So now we spent 14 gas, and we need to see how many units of Wei we have spent. And we said we were willing to spend 300 Wei. So we said we were willing to spend 300. So let me pull up diagram so we can figure out the math to this. All right. So we say 300 Wei multiplied by 14 gas, and the gas units drop. They drop out, and what we're left with is only 4,200 Wei. And that's how much money we had to spend to execute this transaction. So the topic of money will come up every single time we want to execute a transaction on the network. We also have to spend some amount of gas to store data within our contract as well. So all these operations that modify or store data on the blockchain is going to cost some amount of money. In practice, it's not the worst thing in the world, but in reality, things can start to get very rough. There may be applications out there you want to build that can start to get too expensive. Remember, the person creating the transaction is the one who has to pay the gas price. How often would people write on Twitter or Facebook if they had to pay for every time a message was sent out? So this imposes a very strict limit on the types of applications you can expect to build with Ethereum. You're probably not going to find a common user out there who wants to spend $1 just to update their status on Facebook, or spend $1 just to like someone else's post. So this is a requirement on Ethereum, and it starts to limit the scope of the type of applications you can build. Nonetheless, there is a lot of ways to deal with this, and I'm going to talk about some strategies on how to deal with this that don't have to exert a lot of cost or money from users. So that's gas. Let's continue on the next video.